All right, guys, this is kind of a challenge homework problem where you're going to use your knowledge of inverse functions and your knowledge of your trigonometric functions to try to figure out what the domains would be for inverse trig functions. But here's a little bit of a setup. So here's the unit circle. I've already labeled them in radians from 0 all the way out to 2 pi. And notice down here, I've also labeled this guy negative pi over 2 because that might be something that you can use. And a couple of reminders. Remember that cosine of theta is x over your radius, x over r, but since we're in the unit circle, it's just going to represent x. Sine theta, again, is going to represent your y. So those are kind of the values that we're going to look at to determine, are we talking about positive numbers or negative numbers? Now, when we're talking about inverse functions, let's do a little review here. If we had, let's say, just the cosine of 30 degrees, we can do it in degrees first. And we know that that gives us a ratio output of the square root of 3 over 2. But if we were to take the inverse function, that means our input is now that ratio, the square root of 3 over 2. And our output, you would think, okay, well, it gives us 30 degrees. But if you recall, there are multiple angles that can give us that rad 3 over 2. For example, here is, like, for our x value, there's our rad 3 over 2. Let's say that's our 30 degrees. Okay, I didn't put it in a very good place. We'll just move that over. Beep. All right, so there's our rad 3 over 2. But there's another angle that would have that same x value, in other words, that same cosine value. That would be down here in the fourth quadrant. So if you remember that inverse functions, matter of fact, any function, for every input, there has to be a unique output. Sorry, that didn't show up there. Has to be a unique output. That's why we have to restrict the domains, okay? So think of it this way. If we do cosine of an angle, it's going to give us a ratio. But if we take the cosine inverse of that ratio, we need to get only one unique angle. So keeping in mind that that ratio, that answer for all the cosine and sines are somewhere between 0 and 1, right? We go all the way up here. We get a y value, which would be a sine value of 1. Over here, our sine would be 0, but our cosine would be negative 1. Oops. I should have put that negative 1, not 0. See, there you go, from negative 1 to 1. So what I want you to do when it comes to cosine and sine, I want you to match, in this next problem, the function inverse, the inverse function of the trig, and which two quadrants would give us all the possible angles or all those possible input values where they only meet one angle and every input value is met as well. So give that a shot, see how you do.